So we'll start. All right. So here's the agenda. So this is what we're planning to do. So first, just talk about the exam format. Number two, we're going to look through the APCSA course and exam description. Number three, we're going to look at important tips and tricks. After that, we're going to look at a APCSA practice FRQ from the College Board. And finally, I'll answer any questions we have remaining time. So let us get started with the exam format. And I got that pulled up.
You have the full exam, by the way? Did you take it last year, the full exam?
The full exam, yes. And
okay, so there was nothing cut out last year?
There was nothing cut out last year.
Okay.
It was just online. So, okay, first, understanding the exam format. So first, it's multiple choice, and there's 40 questions in 90 minutes. And this seems like quite a lot, actually. So quite a lot of time for 40 questions. But I'll talk about this later, as like some of these questions are really time consuming. So some of the questions, for example, they trace to a bunch of code. You might have done it in like CS class, right? So it's like trace through this like multiple iterations of a for loop, for example, and just like you got to trace through code and then actually figuring out the answer. That takes a lot of like mental processing, and that takes up a lot of time. So 90 minutes for 40 questions, that is definitely, I wouldn't say it's the most time rigorous in comparison to the other AP exams, but it is definitely, you have to be on it. Otherwise, you're not going to finish on time.
That's what 2 minutes and 15 seconds per question, right?
Yes. 2 minutes, 15 questions.
About there.
Yeah. So
that doesn't sound horrible, but knowing College Board, they're going to throw us curveballs. They're going to make me think. So
yeah,
that's the important thing to anticipate, is that the time constraint isn't bad. It's just the questions that they ask are tricky at times.
Exactly.
Yeah.
So, okay, there's apparently in the course and exam description, they have computational thinking practices, and we'll look at that in the CED. I don't necessarily know what each of them are, but apparently they are assessed. I don't think they're super important though. So yeah, but like they're pretty much spread out between all the topics. I mean, of course, you're not gonna have a lot of like println stuff, but like just the more like basics. So you're gonna have like conditionals, arrays. Those are the big parts.
Lots of syntax.
Like, what do you mean by syntax?
Well, like lots of syntax. It'll like ask you like, implementation for code, et cetera, et cetera.
Yeah, exactly.
Right? Yeah. You're not going to be tested on logic as much. That part comes in the FRQ.
I mean, actually, I would say that logic is tested quite a lot on MCQ, because syntax is like a very rudimentary thing compared to like, logic. There is a lot more logic than most people assume.
Yeah.
But all right. After the multiple choice, there's the free response, which there's 4 questions in an hour and 30. And I actually didn't really know this until like 1 week before the AP exam, but apparently there's like specific types of questions that they have to ask for each question. So for number one, number one is like, if in APCSA, in the strides classroom at least, it was exam 1 and exam 2. I don't know about exam 2, but like those types of questions, those are like a lot of methods and control structure. So it's just like basically write a method to do something. That's what question 1. So it's actually probably one of the easiest questions. So there's that over there. Number 2 might be, okay, it can be challenging for some people, or it can be super easy because you're writing a class here. And it's like, okay, you have to have all these specific parts for the specific class. And usually this question takes the most amount of time, but you just have to, they give you like checkpoints. It's like, okay, you need to have this constructor, you need to have this functionality, you need to have all the functionality for this class to work. So that's the class question up there. Question 3 is the array list. So that's specifically on array. So there'll be one question specifically on array and array list, which I think is pretty cool. And then question 4 specifically for 2D array. So I think if there is one thing or 2 things that you're going to study for this exam that you should study, it's arrays and array list and how they work, and like how you can like arrange them, how you can like populate them. I think that would be the most useful, because like studying arrays, you can study a bunch of other stuff along with it too. Like, conditionals and if and else statements, you can do that with arrays, right? So you're getting, you're getting the most bang for your buck if you're studying arrays and just following through that. And a lot of tracing code stuff that happens with arrays as well. So it's good to be careful with that.
And they're super specific too.
Yeah, they are.
Arrays have like, obviously as far as like any other class goes, arrays have their own methods. So like .toString or whatever, or deep toString. So kind of, I don't know. Is like skimming effectively over a couple like string, array list, integer, that those kind of class methods, is it useful at all? I'm just
Yeah,
curious.
some of them, yeah. So for
Okay.
example, the array list methods, actually let's pull up this is the Java quick reference that you get on the AP exam.
Oh,
So
sweet.
you yeah, so you get all of these there's probably like okay, if they're giving you min and max on here, probably they're going to expect to do some sort of min or max on the AP exam. Like it's a possibility, right? And this just means element. Oh, this is for array list. So yeah, this is array list stuff. So get, set, remove. So these are the most basic methods that like if you don't know what they are, I mean you should be able to use them. But note there are specific methods on here that you should know, but they're not on the sheet. And I think just by coding a bunch of projects, I guess, for example, like in order to get an int, what is it? You can just do integer.parsing, for example. So like just knowing all those different types of methods as well will help on this exam. So yeah, make sure, I guess, get familiar with this because I know compare to, for example, that's kind of confusing when I first learned it. But okay. And oh yeah, this and other. Oh yeah, yeah, yeah. Okay, so you need to
Yeah.
know that this is particularly an object of this class, and then others like another object of the same class. Yeah,
When it's
but
ever
like
talking when it's talking about this, it's just always referring to the instance field. Always.
always referring to the instance.
Always. So the original instance field, when this is applied, so if it's like if you have a private instance field, say private string name, if you said this dot name and you assigned it to, let's say, foo, then if you got name, for example, you would get foo. It
Mhm.
would belong to no object, it would belong to itself. It is the property of the instance method itself, or the instance field itself. So it's important distinction to make for this, because I know it trips people up so much, and then they don't know what to set it for when writing constructors. So
Exactly.
yeah.
So that is very important to know what this refers to the object of a class, and yeah, it refers to the instance field, right? So yeah, just get familiar with this. Yeah. What is it? There's okay, I think big one right here. Length with parentheses that refers to a method of the string class. So if you want to say a length of a string object, then you use parentheses because it's a method. But for arrays, for some reason, it's just an instance field of the array class. So if you want to like call like the length of an array, it's length. So it's dot length, but with no parentheses because you're calling it an instance field instead of a method. It's kind of crazy on how these Java, the people who made Java, I don't know what they were thinking by doing that.
Oh,
I think,
you have to also be careful, like the off by one stuff for some of the methods, like substring and index always start at
oh,
0.
yeah,
You
exactly.
have to know that. It's gotten me a few times. You have to know that substring and index, if you said you can have 0 as a parameter in those methods, because index sub and substring can start at 0, just like a lot of for loops can. And what AP Classroom, I've seen this happen in Barron's and even on the practice, like the actual practice tests,
Mhm.
the released like practice tests you could get on College Board, that they write a for loop and then they start at 1. And we're all used to writing for loops. At least I am. I start mine at 0, and
Mhm.
then your entire solution is off because it's an off by 1 error. So it's very important to know that they'll do that to you.
Yeah, so actually, here, let me just say, yeah, all for loops, like I would go from, okay, I don't know if this is easy to see or anything. Oh, there we go.
Yeah, that's fine.
Yeah. But like for loops, okay, I would say from yeah, I'll always start from 0 as well. And the main reason why is because what is it? Arrays and even strings too, like and are like what they are 0 based. So they start from 0 and they go to some length, but like they go to like okay, for example, let's say you have a string, right? So you have a string, let's say like Bobby, for example. It has string length of 5, but if you start from 0, right, it'll be 0, 1, 2, 3, 4. So the last letter would be one less than the overall length. So if you were to get just substring, right? Let's say we wanted to get just Bob, right? So Bob just goes from 0 to 2. But the thing is, if you want to do substring, right, then it'll be like string, let's say cool. That's equal to new. Oh no, not new, not new. It'll be okay, let's just say it's Bobby, and then you do substring, and you want from 0 to 2. So then, come on, I didn't spell substring right. But then here, what you need to do is actually 0, comma 3, because substring, it goes from inclusive. The first number is inclusive, and the last number is exclusive. So basically from 0 to 3, right? So that means you're including index 0, but the outside you're excluding 3. So it's everything before 3 and including 0. So it'll be 0, 1, 2. Similarly, if you had let's say 0 to 4, right? So it'll be 4 will be exclusive. So then you'll have 0, 1, 2, 3. And this would be this would just be Bob with 2 B's right there. Okay, this is a very, I guess, important, is it gets strips off a lot of people, like know where what's inclusive, what's exclusive, know how these indices work.
Oh, and also for like the test case, make it less than 5, not less than or equal to 5, because you will get I don't know what kind of exception will it throw. Is it index out of bounds exception?
Index out of bounds, correct.
Yeah.
So
right.
like, so let's say we had string cool right here, right? So we have cool dot length. So yeah, we want to go, if you want to iterate through the entire thing, then we go from 0 and then we go to cool dot length, where it will be exclusive. So we'll go right there. So I don't know if it will be like useful to like memorize this sort of structure right here. I think
it is super helpful.
Because if you want to go to 4, right, just to 5, but less than 5, right? So we'll go to 0, 1, 2, 3, 4, but then 5 is not less than 5. So then you're done over there. But let's say if you had equals to, then you also go to 5, and then like you go over here, but then it the indices are gone, right? Basically, you don't have any more indices, so you're just going over it, but there is no string, so you have that index out of bounds. So
technically, your for loop will go to only 4 because you said cool dot length is the substring, so it'll only be.
Oh yeah, okay, yeah.
So as long as
technically, yeah.
As soon as it gets to 4, yeah, you're gone.
We're done. So then you'll get the entire thing. But yeah, okay, we went on a slight tangent there, but I mean, I think it's a pretty important tangent.
No, because like even like when you're traversing arrays, you're traversing like 2-dimensional arrays. This kind of structure is so helpful. Wait, actually, do you want to like write down like the structure for 2-dimensional traversing through an entire 2-dimensional array? Yeah. I would memorize this religiously because they're gonna ask it.
Traversing 2D arrays. So then let's say we had let's create a new array, right? A new array, and we'll call it double or something, I don't know. And we create a new array, and then sure, we can come up with random like 4 and 5. So this is a 4 by 5 array. That means this is going to have 4 rows and 5 columns, right? So 4 rows and 5 columns. So then now how you traverse the arrays, you first go through for each row. So basically then now we have 4 int. Here, let's use I. I is equal to 0, and then you go through the row dot length. So that would be I is less than array dot length. So this would give you the row length. So this would be 5. So sorry, 4. So we'll go from 0 to 4, not including 4. And then it'll be I plus plus. And then within each row, you want to iterate through each column. So okay, that's a weird in that, but for each column. Then you go for each column and you go in j to 0. And then here you got to be careful because you
0.
Yeah, it's array, or yeah, you can even say array I. I mean, you could do that. Right?
Would that work?
Yeah, that would work because you just so basically a 2D array is an array of arrays. So I'll just say that 2D arrays are basically arrays of arrays. And basically means that for each column, right? So each row it's its own array. And then you can go through each of that. So array.I, right? So then that would just be of that first row. That first row has an array of all the columns, right? And the second row is an array of all the columns. So then basically over here, we can call this of I. So then from each row, you're getting that array. So you're getting that arrays of length. So that's what this means right over here. And then J++.
The
And
cool thing is that it stays constant, right? So you could technically put in 0 for I, right?
you
Because
could put in 0. Yeah.
because no matter what, your column count is always going to be the same as defined by your array up above, right? So,
Exactly. You can put in 0 there. I think, yeah, that would be better.
Yeah.
But that is the structure for 2D arrays.
Oh, and then just curious. I don't know. I know we're totally going off on a tangent, but
No,
I
that's
think like we just covered like 2 FRQ, like basically the structure of 2 FRQ questions. But you might see like a for each loop traversing through a 2-dimensional array. This has happened as well, especially on the multiple choice questions. That's important
yeah,
to know what they do.
Actually, yeah, for each is very important. I would say for each is especially important in array lists.
Yeah.
I don't know. I just see for each a lot in array lists. And yeah, so
Yeah. So you like create a new array list object. See.
yeah, so like so here we're just creating a new array list object array. So then yeah, you have these brackets right there. You have string. I like the word pool. Let's say sure. Is equal to new array list. Then you can just do that right there. So I mean that's how you can create an array list right there. And it's like, hey, you want to traverse through each string, right? So this is a string array right here. This is a string array. So if you want to traverse through each of the items, you do for string item of the array list. And then yeah, that's how you basically go through. It's actually super simple. So whenever you don't oh yeah, that's it. Whenever you don't need an index, then use for each. I think for each always wins over for, like just a normal for loop. But if you actually need the index, then I would suggest, I mean, you can't really suggest, you have to use indexes or indices. But if you don't need the you don't need the index, then you can just go straight. All right. Let's go back to, okay, we're looking at the quick reference. So just get familiar with that. All right, this is not, there we go. So let's go back to here.
I don't know when you took it, but did you get like a lot of math.random or questions?
Yeah, I remember using math.random.
Okay. They don't use random class though, right?
No, they don't use the random class.
Okay,
The random class is like specific to the UW curriculum. I don't know why they use that, but
that's so nice though. I just use that to generate a random number because I can never get the math.random like includes like the inclusive parts of it, right? It's like generate a random number between 1 and 31, and then they have to be even, right? So that's like, yeah.
That's also a tricky one too. That's
It's like times 16 in parentheses, then times 2 outside the parentheses plus 1, right?
Yeah, let's actually do math.random. I think that'll be pretty. So math.random, that produces a value. It produces a value between 0 inclusive and 1 exclusive, if I'm right. Yeah, I don't think so. It produces 1 exactly.
Yeah, I don't think it does.
Yeah. So,
yeah, it goes to 0.99 as a double.
Oh yeah, as a double. So then
it's always in doubles. So you have to, if you want an int, you have to explicitly cast it as an int for generating this number. You have to be careful for that.
So this is the, I know, I also can say that this is a double, right? So then math dot, so then you have int, then if you do int dot math dot random, then that would just give you 0. Yeah, that would just give you 0. Because yeah,
0.99 gets casted to 0. Yep.
Yeah, so yeah, what is it? It does, Java does truncation, right? So it doesn't round, so no rounding, but yeah, no rounding. It just cuts off the decimal.
Yeah, when you're casting it to an int, that's important. When you're if it's like a float or a long, then it's different. But
Yeah, exactly. Yeah, floats and yeah, those they keep round, but with doubles to ints, it just cuts off. Okay,
Yep.
so then now let me try to remember how they were. Okay, so let's say if you want to, oh, I think I remember how this works. Okay, so let's say we had math.random. Let's say we multiply by 36, right? And we want to. So let's say, I don't know, I bet. So let's say we cast this to an int, right? Now, like, let's say the question was, what is the range, right? What is the range of this? Well, I remember that when the number that you multiply by, so 36, that is the range technically. So the number of numbers in your integer range is 36. But the things that math.random always starts with 0. So they need 0. So for example, 0 to 1, that's a range of 2 because it includes 2 numbers. So 0 and 1. And let's say if it had a range of 10 numbers, it'll be from 0 to 9. So the last number is 1 less than the range. So here, the last number would be 1 less than the range, so it'll be 35.
yeah,
So
I like to
then-
call it like the max minus one rule.
Yeah, exactly.
Yeah, so like your max, your whatever your finite range is, it's that minus one because
Yeah.
0 is inclusive and is counted as a value. So
Exactly. So right here, whenever you multiply by math.random, that gives you the range. So 0 to 35, that is 36 numbers. And then when you add something, like say, then now you add like 5, right? That increases all of this by 5. So it'll go from 5 to 40. Okay, now let's say we want to create a range from 35 to 78, right? If we want to create that specific range, now here's what we want to do. We can reverse engineer this, right? We said when we multiply by 36, right, that's the range. So whenever you multiply that, that's the range. Here, the range is 78 minus 35, which is 43, but then you got to add 1. So because from, what is it? I think it's just with counting in
35
general.
is inclusive, remember.
Yeah, it's
why
inclusive.
it's
So it includes
44,
35. So the range is 44. That means we have to multiply by 44. So we can start, we can say, okay, int math dot random. We can say, and so then we can start multiplying by 44. So that will give us the range, right? And everything starts from 0. So if we want to go from 0, we want to start from 35, right? Then we just add 35. And right here, we've created the range that represents this. So I've given this example. So when you multiply, that's the range.
It's 35, sorry.
Oh yeah, 35.
Yeah. Oh, and
Yeah.
maybe like kind of explain like the difference between putting that plus 35 inside the parentheses and outside the parentheses, because they can have different consequences.
That is true.
Because remember, one of them, like you're taking this entire value, say if you're multiplying math.random, which is 0.99 times 44 plus 35, and you're casting that as an int, you're casting all of that as an int, as opposed to doing math.random times 44, casting that as an int before, and then adding the 35. That can have.
Yeah. So there is a difference between this and. Oh yeah, wait. Are you got anything? So there's this. These are not the same thing. So this one can provide a number between 35 and 78, but this one right here, the only number they'll always give is 35, because casting always takes precedence. Oh, you should know that too for the AP exam. You should know operator precedence.
Yep.
And like casting is also precedence as well. So
So
here,
is casting unary?
yeah, I think
Yeah, right. Yeah. So unary comes first before PEM does.
yeah, this is one of the most annoying things of CSA, in my opinion.
Yeah, I would look up unary operators and know what they do. I think there's only like 4 or 5. But they're all equally important, because it's like and even a more common version of what you put there, Chendur,
Mhm.
that times 44 outside of the parentheses isn't as common. What they do is like they have the 44 inside the parentheses, and it's always the addition or the subtraction that's
Mhm.
outside, and that confuses people.
Oh, wouldn't that still be the same thing as the 35 to 78 range?
Yes, it will, but it's different. But sometimes what happens if it wasn't casted to an int, then it would be different, right? So
Wait,
it
wait, are
is
we?
entirely dependent on the circumstances that they've put you in. So
Yeah. Would they go that nitpicky into like unary? Because like honestly, I don't even remember that.
yes,
I don't think so. For math not random, maybe honestly, because okay, you only have 40 questions.
I did on his exams. I mean,
He did that on it. I remember
So-
history
I
because
don't
of
remember
that,
that.
that's just speculation. But like, do you remember like exam 2, Harini?
Sure.
Right? You remember like do you like there's like at least like 2 math or 3 math dot random questions. So
Are there
It's like one.
them on the AP exam? All right.
yeah, they will be.
there might be. Just be on the lookout because math not random. Like okay, College Board likes to test you on stuff that can be easily be manipulated or like that's very commonly missed. Math not random is
One of
definitely
them.
one that's missed. Substring is definitely something that will be missed. You know,
Or
because
for loops.
for loops, yeah, iterating to for loops is something that will definitely.
Oh, and one thing, like just as a PSA to everybody, one thing that will not be on the test, and I repeat, will not be on the test, is file processing. That is completely unique to CHS curriculum. So you will
That's-
not see any file-based questions.
Yeah,
So,
and I think there's no scanner.
no, there are scanners.
There probably is scanner.
No, he said there wasn't gonna be scanner
Oh, there
question.
weren't going to be scanners either, really.
Yeah, I don't. Yeah,
Yeah.
I don't see. But honestly,
Wow.
though, like scanner is like so irrelevant. I mean, for getting user input, it's vital. But like other than that, it doesn't really provide any use. So I mean,
Ring dot split gang.
yeah, I guess.
Yeah, that's where it's
I'm-
at.
No, usually, yeah, usually use scanner will just be like, oh yeah, you can use the split method. I mean, if you want to split something, you can.
Well,
you can,
that's only if you're like splitting on specific stuff. I'd say scanner is still better because it does tokenization better than split does, because split is always
But
specific.
they won't test you on scanner.
No, I don't think they will. No.
Yeah, you could definitely use like any method. I think that's what Stride said, right?
Yeah,
Like,
you can use whatever. Like you said, like if they have a math.random question and you use random class, say that was one of your FRQs for whatever reason, and if you use random class to generate a random number, they're not going to ding you for it.
Yeah.
So, but it has to be right. So if you're like going beyond the scope of the curriculum, know what you're doing, because impressive points don't matter.
you just need to do it in the simplest way possible. Okay, so now these are the computational thinking practices. I've never seen this until right now, but 1, 2, 4, and 5, that's what's going to be tested on the exam. So 1 is program design and algorithm development. So it's like, okay, determine an appropriate program design to solve a problem. Oh, I think I know what this is. So like they give you like code snippets and you got to see which code snippet would work. So it'll be like, oh, they give you code snippet 1, 2, and 3. Like which one will work? It's like it'll be like 1 only or like 2 only. It's like 1, 2, and 3. So like that type of stuff.
2 and 3 only, or that kind of thing. Yeah.
Yeah, exactly. So code logic is like the tracing that I was talking about. What is it? So you just go through like for loops and while loops and all the stuff and see if that works. So then you got to be able to do that. Code testing. This is like, oh, it's like, will this code work? It'll give you an example of a code snippet. It'll be like, will this code work? Why? And then yes or no, and then why. And then one instance will be like, oh, it's a runtime error. Or another, it's like, oh, it'll work perfectly fine, right? So you got to be on the lookout of that. And then documentation. I don't really know what this is, but describes the behavior and conditions that produce identified results in the program. Oh, okay. So, oh, I think that's what this. So here's just identifying errors, and here's like why will this not? So this is more detailed. But anyways, I don't think so. This is super important. So let's just get to the course content, what to be looking out for. So here's the exam weighting of each of the units in the biggest thing that you have to be on the lookout for, okay, I don't know why last year, but I had a lot of array and array list questions, and it makes sense. It's around, both of them combined, that's around 22.5% of the exam, right? So about a quarter of the exam is going to be array list. So yeah, that's something to definitely look out for. And also, yeah, so primitive types, yeah, I think it's very primitive stuff. Ruby entry, that's not going to be tested that much. Same thing with recursion too. That's not really tested too much. Recursion, you'll never be asked to write recursive code. You'll be asked to trace through recursive code. And then for that, you just create a table, and then it's like a stack trace. So then based on that, then you can see, what exactly you need to do for that. Inheritance is also not a big thing too. I know inheritance is kind of tricky for most people in AP-CSA, but don't be worried about it. There was not too much. Just understand how polymorphism works, how the connections between all the things work. And then yeah, 2D array and array list, they mostly see yourselves on the FRQ. Doesn't mean it'll not be on the MCQ, but just be unaware that writing classes. Oh, okay. So I get confused because in AP-CSA in our class, right, we do writing classes and inheritance like roughly the same time. So writing classes, yeah, you should know how to do them, how class, like, why we need a constructor, getters and setters, why we make everything private, encapsulation, so that type of stuff over there. And then iteration, I mean, that's building block of AP-CSA, right? Like know how to iterate through for loops. That's how you get a bunch of stuff done, basically, right? And Boolean expressions and if statement. So if you're to focus most of your time on the CP exam, just understand how to iterate through for loops, I guess. Know how to get calculations done. Know how to, like, and if you're given a specific problem, how are you going to do it? So based on that, you can go ahead and study. I think here I'll take a screenshot of this.
And really quickly, do you want to go over recursion?
Recursion, yeah, we can go over recursion. Yeah, we could.
There's only like one small thing that I want to say when if there's any recursion required. I don't know. Did you get any like last year on your FRQ?
Recursion problem, I think so, but
okay.
Honestly, the recursion questions are super simple in terms of like tracing through.
You don't have to write it, right?
Yeah, you don't have to write recursive code.
Okay, yeah. Because I'm like, if you have to write if you do have to write recursion on whatever off chance that they do put it there, just think about it this way. Analyze your exit strategy. So just know, okay, when I'm going through this and I'm tracing through my recursive program or method, where is it going to break? Where's my fail case? And that's what you should put first. So before you even write your method, have your exit strategy as the first thing, should they put it. So
yeah,
that is something that I like to do.
Recursion. Yeah, I think that's a very good strategy. Write the base case first.
Yeah, or base case. Yeah.
Okay. Yeah, but yeah, base case first, because that gives you the basis, and then it gives you like the idea of where you're headed to.
I don't want to like sound redundant, but it gives you your parameters.
Yeah.
To operate within, right? Because you don't want to write a program where it's going to call itself, it's going to return itself by calling itself, and then you're like, oh shoot, this is going to break because I hadn't established my exit strategy or base case. So
yeah, exactly.
Yeah,
all recursion problems have an end goal. If there's no end goal, you might as well not write the recursion.
Yeah, you just break your program.
Just Stack Overflow. All right.
Oh, is it Stack Overflow?
Yeah, I think.
Too many stacks pushed on, right? Yeah, the register. Yeah. Okay.
Okay, so let's just go quickly. Just something. Primitive types. Casting. Probably the most important one is like casting. All the other stuff is like very basic. I think most people will understand it.
Yeah.
Void. I think you have knowledge of that name. How to call methods, concatenation. That's also very like basic stuff. I think
out of all of those, using math class, string methods, and what I just saw something, concatenation are probably the three most important parts of that second unit by far, especially concatenation.
Yeah, concatenation. Yeah. um here Boolean. Oh yeah, of course, like how to use an if else, right?
Oh yeah, De Morgan's law, people.
Oh
That's
yeah, De Morgan's law. Getting them
it never ends.
in never. Yeah.
Yeah,
Okay. Okay. Let me just go through some more.
yeah. This is something important to go over.
De Morgan's.
2 wrongs make a right in CSA.
So let's go through like a test case. So it's like not. Okay. Not A and B. Okay. So let's say. Okay, actually, there's no need for double, but let's say we have not A and okay, these are like 2 statements. Like think of these as like Boolean statements, right? So we have not A and B, right? What we can do is I like to think about like factoring the not, which is kind of weird, but like here, just hear me out here. So if we factor out the not, then we have this expression right here. So then not, what we have is A. And then whenever we factor out the not from and, that becomes or. And then here, there is no not here, but like not means like false, right? So then what is it? Not times not is like true or like nothing, right? So here's like you have not, so you have just B here, right? But then in order for me, if you pull out a not, that'll be not B. So if you were to multiply this all back together, it'll be if you just multiply it, it'll be not A, and then not times or is and then not times not B. So it's not B, that is B, right? So then this is how I think about the more.
Yeah, no, that's like it's like 2 wrongs make a right in CSA.
2 wrongs make a right. Yeah, you can think about it that way too. That's a much more simpler way. So that's how I think about it.
Do you want to I was wondering, I actually have a really good practice question for De Morgan's law.
Yeah, sure.
It's actually really good. All right, so hold on. Do you want me to share my screen and then you can attempt to solve it?
Yeah, sure. Or if you can send me the link to that problem or something that
Oh, actually, yeah, I can drop the link in the chat. That's fine. Yeah. All right, here you go.
My bad.
There you go.
All right.
And I believe it's question 4.
Question 4. Okay. Yeah, I'm just gonna take this and put it in here.
The funny thing is that their progress checks are always harder than their exams. I don't know
Oh,
why.
actually, that's a good point to mention. The progress checks, what is it? The progress checks are actually very similar to the difficulty of the AP exam.
Oh, is it really?
Yeah. Or
Okay.
actually, the progress checks, some of them are low. I think it was like the AP exam was slightly harder than the progress checks. Just slightly. It wasn't like terrible. But okay. De Morgan's law, let's go through. Okay, this meeting might go overboard in terms of like time, and I'm perfectly fine. I can stay here until like 7:30. That's not a big issue for me. I just want to go through like a practice FRQ though, because personally, I feel like because 50% of your exam score is FRQ, and I feel like for most people the FRQ is a strong spot. Compared to in other exams, a lot of people do a lot better on the MCQ than the FRQ. But for CSA, a lot of people can do so much better on the FRQ. You want to do well in the MCQ as well, but FRQ, that's where you can gain the most because there's a lot of partial points in the game. All right, so De Morgan's law right here. So I think of it just like math, right? So first we want to deal with the inside most as much as possible, right? So I'm going to distribute this not. So I'm just going to carry this over. But then here I'm just going to be like, okay, this is not A, and then not times and is or, and then this is B, or yeah, not times not B. So then we have this right here. Yeah, there we go. So then, yeah, I just factored that. I just multiplied this inner not with A and B, so it's not A or not B. And then here Okay. I dealt with that. So then now we go to the outside and then we multiply to each one. I think here it'll be, so not times not A is A, not times or is and not times B, not times not B is B. But then that was A and B were in parentheses, so I'm just gonna keep that in there. Not times and, so sorry, not times or equals and. So yeah, whenever you have not, it flips the and the or. So that's a good thing to note. And what is it? C, not and C is not C. Then not times or is and not times not D is D. So A and B and not C and D. So okay, never mind. A and B, not C and D. So
B.
the answer is B.
Yep.
Really?
Oh, sorry.
It's A.
No, you're right. Never mind.
Yeah, I
It's
think-
it's C. What am I talking about? I thought it was the her. No, wait. What is it?
I think it's A.
Oh, is it A? Sorry, I can't read it at all. Yeah, there we go.
There we go. So yeah, based on that, so it's basically math. That's how I think about De Morgan's law. It's just a different type of math. It's
Sorry,
just-
I totally mistook those or signs for ands for whatever weird reason and use that. Sorry. It's my
Okay,
bad.
so not times not is nothing. It makes it like normal back again. Not times and equals or, and then not times or equals and. So those are the key things that we need to discuss here. So that's De Morgan's law. Okay, that's
That's a nothing / normal for not times not.
oh yeah, nothing plus normal. Nothing plus normal is equal to-
Or like you could put / normal at the yeah, equals not.
yeah.
There you go.
Look at that basically slash normal something. Yeah, sure. It's backslash something. Anyways, that is De Morgan's law right there. All right. I think it's a good time to go through a practice FRQ. Yeah, it's a good time to go to practice FRQ. Here, I would just say, yeah, know how to use if-else statements, iteration. I mean, say it's the biggest part of the AP exam, but the thing about AP, CSA, is a lot of stuff is combined together. So you have like array list and iteration together, or like, just 2D arrays and iteration go together. Then you have like array list and then if-else, right? So anything can go together. So a lot of these can go together. So just looking at the why do you call it CS? Just looking at the AP CSA CED will not necessarily help all the time, but it is good to know. It's like, okay, I need to know this particular thing. Like knowing what this is, for example, I think that would be very helpful. Array list 2D array. And then recursion, that's, yeah, just know how to sort through recursive code. You'll be fine. Inheritance, oh yeah, know how the methods work. Here, the methods for CSA were really confusing. So I remember if, like, say, dog extends animal, right? So this is a class, right? So let's just say public class dog extends animal. And let's say you say
Animal puppy equals new dog. There's your polymorphism question. If you wanted it.
are you allowed to do that, or is it like
Yeah, no, because it extends animal. Dog is a child class of animal.
no?
It's
I
just
think it would be the other way around. So it'd be like dog,
You-
dog puppy.
Oh yeah.
Oh,
sorry.
it's wait.
The other way. Wait, isn't it
I think-
animal?
Hold on. Let's think about this.
Because
No,
Yeah.
no, you can't do that. Nope.
It's the
Animal
other way
is the
around.
parent class. That does not work. Nope. Because you can't fit a dog into an animal because there could be
Yeah.
class cat, which extends animal, right?
Not all
So-
animals are dogs.
So
Yeah.
you can't fit a puppy into an animal, right? You can only fit a puppy of animal into a dog. I know it's like a horrible analogy, but It's the best one I can do. I'm really trying not to think about a slideshow full of like baskets and puppies and cats.
No,
Did
no,
not make sense. His like basket analogy.
Yeah, the basket analogy. There we go.
Yeah.
okay. Wait, so I actually want to pull this up. Like, is it inheritance, object
Hierarchy is
creation?
Oh, something.
Geeks for geeks. I mean, yeah, this
Geeks for
is
Geeks is so good. I've used that so much.
Apple. Okay, this is not helpful, but
I used it for my date cell, literally. the whole
oh
thing.
yeah. I think everyone needed that.
I use like Java point.
Yeah, I used the API.
Yeah. Like say, okay, I'm just gonna search up like dog puppy equals. It's not gonna help. Like,
Wait,
I think,
actually, hold on. Maybe I can like drop you his slideshow. Hold on.
oh yeah, I think that'll
Yeah,
help.
let me try doing that. Maybe it'll work.
Maybe.
Dog.
Hold on.
Oh.
Slide decks, polymorphism. It's has the relationships, Chendur, right? Is a has a, right? Okay, yeah, that's this one.
But like all dogs are animals, but not all
Mm.
animals are dogs.
And precisely the reason why you can't fit a puppy into a new animal.
Oh, okay, I see. Oh yeah, when you create a new animal,
Right,
it-
because
it-
what happens
it-
if we had a class called cat and cat extends animal?
Yeah.
So then there's some ambiguity. It's like, okay, you have a dog, but you're creating an object of type animal, and there's like some ambiguity between whether it's a dog or a cat. So
All right. Okay, so the reason why I find this important, right? So animal puppy, so you're taking a dog and you're putting this into puppy, right? So let's say you have puppy dot speak, right? So let's say there is a method called dot speak, right? If the animal class does not have speak, code above does not work. So that does actually be like does not work. Right?
Oh, sorry, like I'm totally cutting you off. But one really important fact, he covered this on exam 3 on Tuesday. But really quickly, if the dog class has a speak method and the animal class has a speak method, and you've created a dog, and if you say, you said puppy.act and the act calls the speak method, remember, no matter what, your puppy in this case will always act like a dog no matter what. So your puppy will always act like a dog. So whatever object that you have, it'll always act as its as what you instantiated it as, not as its type. So
Exactly. That's the point that I wanted to bring up. So very nice job there. So if animal has speak and then dog also has speak, remember that puppy, what is it? Puppy is a dog. So it behaves like a dog, calling speak from dog class. So yeah, so if animal does have speak and dog does speak, right? It has animal and dog both have the method speak. Then remember that puppy is a dog, so it'll call the dog's speak method, not the animal speak method. If animal only has speak, then it'll call the animal speak because there's no other speak to call. But if the animal has a speak and a dog has a speak, the dog speak, that's what's going to take precedent. So that's a very super important concept, I think, from polymorphism. I think this is polymorphism. Yeah. So that is
it was the most missed question on our exam. So
yeah, that is a very important point. Okay. If we come up with any other just things we want to cover real quick, I can pull it up. I have the 2019 FRQ question. So I think within the last 30 minutes of this session, I would say, we can choose to do one of these. So have you guys done these before, or do you guys want to like do another year or something? Do you have any preference for that?
Oh wait, is anybody here taking the mock exam tomorrow?
Yep. Yeah.
Yeah.
Okay, I don't know. Is this the one that he's using?
I'm
No.
using 2021
He's using
tomorrow.
2020.
He's using 2020. Okay, cool. I wanted to make sure.
Yeah, yeah. Teachers have like really like secure exams so they can administer to the students for practice.
I think the
These are-
2020 FRQ is open though. So not the multiple choice; those are always locked down, but the FRQ is open. Last time I checked, so that's why I wanted.
Yeah, but
to
I don't think so he's gonna administer that. I'm pretty sure he's
No,
gonna.
no,
be-
he said it. He's like, if you're practicing at home, don't open the 2021 if you're coming to the mock exam.
Oh,
So yeah.
I see. Okay. But anyway, this is the 2019. Which one do you guys want to do? Number one, remember, is this is weird.
The calendar.
Oh, is it? Wait,
Is
number.
it like
This is the class. This is the class.
Talking about like how it's the same as the one like on the exam.
yeah. Oh, the leap year thing too, right?
Yeah. Oh my god.
Okay.
So
So
yeah, it
this,
was like a shortened version of what was on the exam. Yep.
so this is a method count. This is a method and control structures. This is number two, the step tracker. This is the classes. Number three is array. So sorry, it's just an array. It should be an array.
Array/array list.
Array slash. Oh yeah, array list.
And then there's 2D arrays.
Yeah, and then there is 2D arrays. Yeah, this is 2D light boards. Like,
You want to open a poll, Chendur?
I mean, all right. Here's what we're gonna do in terms of splitting this up. Okay, just tell me a number. Which number we have to do? Just like you can send it to me, or which number do you want to do? You can do 1, 2, 3, or 4.
Okay.
Okay, 4. I got 1, 4. Yeah, 2 4s.
Oh my god.
I just 4. Everyone's doing 4. Okay, we'll do.
I don't know why you're freaking out. You'll be okay. I promise. Array list isn't.
No, I
that
don't
bad.
even remember which one's 3. So
Oh, 3 is the array list question. I need to do 2D arrays. I can't solve them for the life of me.
which one is?
Do you guys? Okay, there's 2 ways we can approach
Yeah.
this. One, I could write this in my compiler and we can go through it one at a time. Or 2, I can give you guys time to try to solve this. Which one do you guys prefer?
I think seeing your thought process might help. I'm just
Okay.
curious. I think like obviously we can go and then try it ourselves and then come back like a Khan Academy video, but I think seeing your thought process might be a little enlightening for some of us.
Okay. Yeah, I think that's good. Yeah, anyone can go work on their own, but like looking at how other people do it, I think that's a very valuable lesson. So,
Can you not copy and paste this?
oh yeah, I could do that. Let's see if it works. Yeah.
Look at that.
Dang. Okay, so let's say this is light board. Light.
Wait, you can't run it. Or actually, never mind. Oh, you could run this one. Because most of the time I'll say like implementations like not shown or something.
I am so happy that this is being written in VS Code. I can't stop
Yeah.
containing my excitement.
Yeah, it's a beautiful language.
True Replit.
It's beautiful. Yeah, no, Replit.
It's so
I
horrible.
think everyone can do that. Okay.
Yeah.
It's not that bad.
You're right. It's horrible.
Overhated.
All right.
It like okay, actually it bugs out a lot. But
Oh, No. literally no.
All right. So lightboard, okay. Lightboard class models a 2-dimensional display of lights where each light is either on or off, represented by a Boolean value. So it's either on or off. Okay, so that's why we have a Boolean 2D array. Right. We will implement a constructor to initialize the display and a method to evaluate a light. So then we have this light board right here. I hate how this is like not indented at all. But yeah, I think we'll just deal with this here. Okay, this represents the light on the board. Light board, this is the constructor that has to be implemented. And then evaluate light. Okay, so it's like, I think this is where we turn on and off the light. Okay, so the precondition is the number of rows have to be greater than 0, and the number of columns have to be greater than 0. Post condition, each light has a 40% probability being set on. Probability, what are we going to do here? You guys know?
Wait, sorry, can you repeat your question?
Like
Just
when we're doing anything with probability in CSA, what are we going to do?
I have no idea.
Well,
point?
probability is chance,
Math
right?
are random.
Yes,
Right,
exactly.
yeah,
The random.
yeah.
So we need to do math on that. That's what I'm thinking. Anytime I see probability, okay, that's a chance. So we need to figure out some random numbers. Random numbers, math out random. All right. So let's just go to A. Write the constructor for the light board class, which initializes light so that each light is set to on with a 40% probability. The notation lights are rows and columns represent the array row R and column C. Okay, so first light board, they give us number of rows and number of columns. So they've given us this light right here, a 2D array, but we've not initialized them to be like the length, right? So then we'll be like this. I mean, you don't even need this. Okay,
Yeah.
this dot lights dot this dot lights is equal to oh yeah, we just created the 2D array. We did, I forgot it was like initialized. Yeah, we need to initialize the array.
So equals in bracket num rows, num calls, right?
Yeah, so first we need to create a new 2D
Oh yeah, new.
object, right?
Yeah.
We've just named it right here, but we didn't actually create the new object. The
You need
object
to initialize it. Yeah.
So first we have to create a new array. It's a 2D array. And this is going to be, what is it? They said over here that the notation is going to be rows and columns. So the rows is going to be the number of rows that the user inputted. So it's going to be num rows. And then the number of columns is going to be the number of columns that's inputted. Number of columns right there. Okay, so we got that. All right, so then now we've created this new 2D array. Now, what we're going to do is we need to turn each of these on or off, right? Remember, this lights array consists of 2D booleans. So each of these are going to be true or false, right? So what we need to do is we need to go through each and every light, right? Because we want to see if each light, it has a 40% on or off. So we need to go through all the lights. So then that goes back to our traversing the 2D array, right? So we want to be like, first we want to go through rows. If you want to go through each and every element, first you can go through row by row, and then from each row, we can go from column to column. So it's going to be a nested for loop, one for all the rows, and within each row, then we're going to go to each column. So first we're going to make for each row. And then this is the standard notation to go over there. So we start off, always start with 0 when you're iterating, like we discussed before. I equals 0, that's a good starting point. And then we go all the way to the row length, right? So the row length, or actually the number of rows. So think about it, let's say, there we go. So let's say we have, okay, we got the Rubik's Cube right here. Let's say we have a 2D array, right? So then the number of rows is going to be right here. So this is the row dot length. So here of this 2D array, this would be in a length of, okay, let me bring my thing over here. So I have the Rubik's Cube right here. I don't know if you, when I record it, you can see it, but I'm holding two Rubik's Cube next to each other with a dimension of 3 by 6. So here, rows dot length, that's going to be 1, 2, 3. And then with each row, that each array, so like this is array 0, for example, right? because everything is zero based. So right here, then that would be the length of that. And that's when we do each column. We'll look at each column, then we go from there. So first, we need to go through each row. So it's going to be array dot length, right? So that's just going to go through each of the rows right here. And then we want to define.
Isn't it the other way? Rows go this way and columns go up and down. Or am
Yeah,
I-
rows goes this way. But if you're counting the number of rows, this is row 1. Sorry, this is row 1. This is row 2.
Oh yeah, I see. Yeah. Yep.
So
yep,
that's
there's only
what-
3 rows.
Yeah. So yeah, and then for each row, so we start with the top row. Then we're going to go from the first row, first column, first row, second column, first row, third column, and that's how we're going to go through. And then once we're done with that, then we go on to the second row. Then second row, first column, second row, second. You get the idea,
Yep.
right? So then now we go for each row, and then now we want to go through each column. For each column. So then now we can say call. Actually, a better way to say this, instead of I, is use row. Mr. Scheid would be happy if you did that because I and J mean absolutely nothing, right? If
And
you
Jake can look like your eyes and then
exactly, you can mess
reduce
up.
to hell. Yeah.
And I understand that. It's like if you understand what each of the indices mean, then it'll be perfectly all right. So then now we go for each row. But what happened there? Row. I don't see the error here.
Oh, you have to finish writing it. Yeah. And then it'll.
That's not a okay. That's fine. I guess. Oh, I think I have to finish writing this. Yeah.
Yeah.
Column. So then now we want to go through each specific row. So right here, right, this is the first row or array dot like 0, for example, right? Oh, and also
I think it'd be better to just put array at index row because
yeah, so at each index of the row, now we want to go through each column. So that's going to be, and oh, I also changed this to lights because our array is called lights. It's not
Yeah.
called array, so I switched that. It was array initially, but I switched it to lights.
and you don't need the this, by the way, right? At all.
Yeah,
You could
technically
actually,
you don't.
you
You don't
yeah.
need this technically, but yeah. So then now each column, right? You're gonna go from the row, the array dot row of, and then we're gonna take the length of that. So that's gonna be here in this case, if you were to put that, right, these two together, it would be the length would be 6, right? Of each row, it'll be 6. So that would be an example.
Does array at row have the same function as like array bracket 0?
Yeah, so the difference here is this right here, this gives you the number of rows, this gives you the number of columns.
Yeah.
So that's the difference. So for each row, it gives you the number of columns.
Right. Because I've seen 0 instead of row be used in there.
Yeah, you can also do that as well because of length 0, all the rows have the same number of columns.
Right. Yeah.
So you can also say 0 as well. You can leave this at that. And
So they're interchangeable.
yeah, they're interchangeable. I mean,
Cool.
the only, yeah, go ahead.
Yeah, sorry, just universally think about length as something going left to right consistently, unless it's specified. So if you just look at the lights.length, right, it has a 2-dimensional array, just think about the length from left to right. And a 2D array isn't, like Chendur had alluded to earlier, was an array of arrays. So right, we want to know how many array of arrays there are, and the lights.length will give us that. Now, if you specified it as lights at token 0 dot length, now you're specifying, okay, at each row, how many columns do I have? So it's all about specificity. So if you just say, in general, how many rows, in general, what's the length of your array? You're going to count, okay, I have 1 array, I have 2 arrays, I have 3 arrays, right? But now you're looking, it's like, okay, now it's at lights at 0. Now I'm looking at one specific array. What's the length of that array within my big 2-dimensional array? And that will give you the length. In this case, if Chendur held it up, it's 6. So that's how it kind of works.
Perfect. So then now, okay, so let's finish this. So this goes through each column right here. Yeah, so then we're going to each row and then each column. Perfect. So then now this traverses through all of the spots of the array. Then now we want to see if this spot is, okay, actually, I want to make this clear. So what is it? Lights is a 2D array, right? Or actually, lights is a 2D array. Then lights, and then if you take a specific row, right? That is a 1D array, right? If it was lights, row, column, right? What is that? What would you say, lights, row, call? What is this, like, what type of variable is this?
Array.
Wait, can you repeat again?
That's 2D array.
No, not necessarily. You're accessing an element from the row and column. In the rows and columns, so in this particular layer, let's say this is right. Let's say this is light, not right, light, right? So we go to a specific row number, we go to a specific column number, right? What's going to be in that position? What's going to, like, okay, basically I'm pretty bad at asking questions, but this is a Boolean 2D array. So what are the values that is going to be stored in this 2D array?
Booleans.
Booleans, exactly, right? So Boolean values. So here, basically, we want to make that value in this row and column to be a Boolean, right? So, okay, first we want to say, okay, each light has a 40% chance of being on. So we're going through each and every light, and here's how we do probability, right? So 40%, 40% is 40% is 0.4, right? So now math, we said before that we're going to use math.random for probability. So math.random, that gives probability right there. And this gives us 0 inclusive, 0 inclusive to 1 exclusive. And hopefully you can understand this notation right here. Basically, it includes 0, it does not include 1. But basically, it's like a range of 1. That's what you have to think about, right? So if 40%, so then now we'd be like, if math.random, we want to see if it's less than 0.4, right? So anything, I don't know if it's less than or equal to. Okay, actually, I have a better idea. Because I don't like dealing with random, double garbage, right? Because you have like a bunch of random, you got to say, okay, what does 40% exactly mean, right? So here's what I'm going to do. I'm going to convert to integers. So here, we know we have int. This is math.random. This would give us just okay. First, if we want 40%, right? 40% is out of 100. Let's convert to 100 integers, right? So that means our range is 100. So if we go back to our notes that we took on, yeah, very messy notes, but let's see right here. Yeah, the number that we multiply by, that's going to be our range. So over here, like if we look at this piece of code right here, when we multiply by 36, we're taking any number from 0 to 1, we're multiplying by 36. So we're increasing all the values by 36. So you're increasing that range to go from 0 to like 35. So that would be 36 numbers. And all math.random numbers start at 0. So you go from 0 to 35, and then you can add 5, give you 5 to 40, right? So similarly, we have a range of 100 integers. So we're going to multiply by 100 right here. And then all of this starts, if you were to just do this, it will go from 0 to 99. But now we want to add an extra one, right? So like we want to go from 1 to 100 just to make things easier. So if we want to add 1 to everything, that's how we'll get our range to go from 1 to 100. So this range, this would provide us with 1 to 100. So what I'm going to do is I'm just going to call this probability. Probability. And it's an int. Int probability is equal to this. So over here, wait, does he have any questions?
Yeah, no, I there's probably an easier way, way easier way to solve this. It's a little deceptive, but you actually don't need to compute the math.random value at all.
What would you do?
So you were right with I'd use a double, but what you could do is you could say double probability equals math.random, just math.random.
Yeah, you could do
Okay.
that. But like,
And then what you could say is then at lights at each row and at each row and each column equals your probability, which is what we assign to math.random. Probability is less than 0.4. That's the only 2 lines you'd have to write, and that would work.
yeah, okay. I'm confused if you need to do less than 0.4 or less than or equal to.
It'd be less than 0.4. Yeah, it'd just be less than, not less than or equal to. It's not inclusive of it. So
Yeah,
yeah.
okay. I
Is here
think
less than or equal to, because that'd be
Here.
40, but then that'd be 0 to like 39 point.
I'll write the solution, but
yeah, okay, so here I'll just give you, okay, let me just go through my solution. I
okay,
think
go for it. Yeah, sorry.
so. Yeah, no, you're good. I think, okay, if you're not super versed with math.random, then probably your strategy is probably the best. But like how I like to think in terms of like simple numbers as opposed to like just random probability. So I just know that there's 100 numbers, so I just range from 1 to 100, and then I was like, if probability is less than or equal to 40. Oh yeah, so then I think your method will definitely work, because what you
It's
would
a hard-coded answer. Yeah, it's kind of like jumping the line a little bit, because
No, yeah, so-
you're searching for any value. You create a probability index that has a range between 1 and 100, and then you're looking for that specific 40.
yeah, and honestly, let's just go back, right? So this gives you a number less. So anything 1 to 40 is 40% of anything from 1 to 100, right? So let's say we want to switch this back to 0 to 99, right? So we subtract everything by 1. That means this subtracts by 1, so this goes away, and that means you have to not include 49. So it'll be less than or equal to 39. You technically subtract that by 1, but another way you can do that is just say less than 40, right? And then let's say now you just divide everything by 100, right? So just 0 to 0.99999 something, right? So it just goes on forever and ever and ever. And then so then you just need this right here. And you don't even need the math.random. So you don't even need the integer, right? So then you just have this, and then now this also divides by 100 as well. So this is the mathematical way to think about it. But yeah. So
You don't even need to do that. The cool thing is that it's already a Boolean. It's already a Boolean array, so you could just assign it, and it would say true or false.
yeah, but okay, so we need to, yeah, first we need to say if it's yeah, here's what I would do. So we need to set these booleans to true or false, right? So boolean
You don't even need that. You don't need that at all. What you could say is, so like after your double probability, right after that line, if you say I'm pretty sure this
oh yeah,
works.
you could just say what is it? If probability is less than 4, then you
No, not even, just erase the if statement completely.
Okay, what are we
Right?
gonna do?
And then say lights at row at row and column, right?
Yeah.
Equals probability.
You can't do that.
Yeah, you can.
Remember, lights.
Wait. It's equal to, so I wasn't finished. Is equal to probability less than 0.4.
Oh, probability is less than 0. Oh, yeah.
This
That
would
is-
be the canonical solution.
This would be the best solution. Yeah, because this one will give you a Boolean value.
And it would automatically evaluate to true or false, because if you scroll up a little bit, when we instantiated our 2D array, it was a Boolean array. So it would figure out for itself whether it's true or false.
That is true. So yeah, this is the smartest way for coding. And yeah, I appreciate the solution. It's a very nice, elegant solution.
You have to put, like, make it a variable. Can you just put math.random where probability would be?
Yeah, you can honestly,
That
honestly.
Yeah, you can also do that. Yeah.
So
I
Yeah.
feel like this only really applies to like Boolean logic though, as
Yeah.
opposed to say like if the array is dealing with integers or doubles or what have you. So I think there's still value in going through the other way, but yeah.
Oh, wait,
I like
I have a question. If we trace through every time the for loop went through, would it compute a new math.random value, or would it store it?
it would compute a new math.
It would compute a new one, right? Okay, so then
Yeah.
it does work.
Math
Yeah.
random is always random unless it's stored. Then if
And
it's
there you-
stored, then it stays there.
Yeah, you got your canonical solution. There you go.
Yeah. So
Yeah, one line of code.
But I do have one thing to point out. You're not going to be graded on pretty code.
Yeah,
Yeah.
you're
So
not.
You can write the most
Do
like,
whatever works.
complicated way. You
Yeah.
can do whatever works. So like for me, at least how I like to think, like how I write code is like how I like to think. It's probably not the most dry method, and honestly, it's not the best too. But but like for the APCSA exam, that works. You got to realize that APCA exam is not necessarily like real world. You can do like whatever you want to think to do, and it'll hopefully work, right? So that's how I like to think about the APCSA exam. But I think we're done. With, hey, actually, we just said everything.
I have a quick question about creating the lights object. Would you not say new Boolean?
It was created above.
It was created
Right.
above. Right. So
So-
you wouldn't have to say new Boolean again?
No.
So
in
yeah,
the
so
Create it.
usually usually you'll be like Boolean 2D array lights
Mhm.
is equal to this right here. If you're doing the declaration and the initialization at the same part, here you're declaring an object and then you're creating the object on the same line. But if you have instant fields, you've already declared it. What all you need to do is you need to make the object.
Mhm.
So there's two
So
things.
You
So
could
you can
technically
use
say new
R?
Boolean too.
Wait.
Sorry, go ahead.
Yeah, go ahead. Sorry. Wait, can you repeat, Daniel?
oh sorry. So wait, so you can use R?
So right here.
Yeah.
Yeah, so here's where we're creating the new object. So like over here, we've declared, okay, we have a 2D array of lights, but we've not actually created the 2D object. So anytime you have an object, you need to have the new keyword. So that's the first thing you need to do whenever dealing with objects.
Right.
I think what she's getting to is like you can also say lights equals new Boolean too, right? I mean,
Okay.
it doesn't matter.
Wait,
Right.
Okay, that makes sense.
You could say that too. I'm pretty sure you could say that. Yeah.
I don't think.
You're right, because you're creating a new Boolean array. Your array, your ARR just encompasses.
Oh, I screwed that up. Okay, yeah, I don't know what I was doing. I don't know. Oh, my bad. My bad.
No,
Okay.
it works. It's like this is the best way I can explain it. But like, do you know like the exception based class when you do a try catch?
No, okay. This is complete BS.
No, that works. No, it actually
Wait.
works. There's a reason for it.
Okay, but I don't think so. They're looking for that. I think it's
Yeah,
Boolean.
no,
Okay,
no,
thank
yeah.
you, Daniel. Okay, thank you. Okay, I was
All right.
Yeah, okay. I understand you now. Yeah, so you need the string type. Let's think. I don't want to deal with that. Yeah, it could work, sure, but like this is what they're looking for.
Yeah.
Okay.
Yeah, I'm so sorry for that. I only caught that right now.
That's
but-
all right. Thank you.
Yeah, of course. All right. So then I think
Part
that's
B?
just yeah, just go part B. So then we set everything. Yeah, we're good to go. Part B. Oh wow. Okay. Write the method evaluate light. Oh, that's it. That's the only thing left. Try to do this. Evaluate light to be implemented in part B. Okay, let's just do it here. Competes and returns the status of the light. Okay, returns. Can I write on this? Let's see. Oh dang, can't write it. But never mind. Return false is the number of lights.
Ah. I have to go. Thank you.
Yeah, of course, man. See you later. All right. If a light is on, return false. If the number of lights in its column that are on is even, including the current light. If the light is off, return true if the number of lights in its column. Okay. So they're giving us a light in a specific row and a column. So new light board. Okay, this is an example. Okay, so this is a 7x5, so it goes from 0 to 6, 7 rows, and then 0 to 4, which is 5 columns. It creates a light board with the initial state shown below, where true represents a light that is on and thing is false. Okay, so this gives us a board. So this doesn't have to do anything with the actual like code right here. So if we use 0, 3, so 0, then 0, 3, that's true, right? If the light is on, so this is on. So if it is true, then return false if the number of lights in this column that are on is even, including the current light. So 1, 2, 3, 4, it's even. All right, it's false. And then similarly, yeah, go ahead.
It's kind of weirdly worded, but it's asking, is the light off? That's basically what the method is asking. If it's off, then it's going to return true. If it's not off, well, it has to return false.
Yeah.
And they don't say that. That's the problem. That they don't say that. So you have to make that. Distinction for yourself.
Yeah, that's true. Like, okay, yeah, you have return false if it's on return, but like, you also have to satisfy this condition as well. So
no, that's what I said, right? Yeah. So if your light is on, so like I said, the big question it's asking is the light off? If the light is not off, then you have to return false because you want to ultimately satisfy the big question that they're asking you.
Yeah, but then you also have, if the light is off, then you go to this statement right here.
And if the light is off, yeah, you return true.
It returns true if the number of lights in its column are
divisible by 3. Yeah.
So yeah, you need to have all these specifics. So you got to make sure those are down.
Yep. Yeah.
So first, we'll be like, this is, I can use Boolean logic. So like whenever they have if statement right here, like you can literally like write an if statement right here. So if the light is on, so that means the light state is true. So we can access our board of lights, and in our lights we have a row and we have a column, right? So this is going to be that specific light, and this already is going to be either true or false. So there's no need to say equals true. I mean, on the exam you could do that for sure. They're not going to document anything, but this is that it teaches you about Booleans. So I'm just going to do it, right? So if true, then what you're going to do, and also technically this is an and statement. So if it's true, and number of lights in its column. Okay. Okay. So then actually, I think what we should do first, because if you look at both of these statements right here, so number of lights in its column. So we're going to count the number of thing in its column right here.
You're going to have to need an int on or on count or something.
Number of on, right? So number on, that's going to be 0, right? And okay, so then let's just go through each. So int call equals 0. Call is less than
lights.length.
Yeah, lights.length. Or actually, no. Lights.length
would work.
Oh yeah, because we're going through each row. Yeah, you got to think about it though. So we're going to each row. So each row that'll be lights.length. If we're going to each column, it will be like lights.0. So lights.length, and then call plus.
And then you can say if and then I actually had copy and paste that if statement right there in your body.
I mean, this one, if
lights at
Oh, I can't use this call right here.
Yeah, you
I
have to
need
say row. You have to say row. Int row.
int row. Yeah.
You have to say int r. Yeah, just say r. Rows.
Row
Row num. Yeah.
Yeah,
Something
sure.
like that.
Like this row num. I mean, it doesn't matter.
Yep.
Row num. Because we're going to go through each. When we're going in that one column, if we're traversing the column, we're going through each row number. So row number, and then row num. So right here would be
Row
like,
num. Yep.
yeah. Here will be row num, and then we're staying the same column. So column number stays the same, but the row number changes. So if
Yep.
true, then if that's true, then we do number on
Plus. Yep.
number on plus.
That's it. Yep.
Yeah. Number on plus, and then we'll just add on. So then okay, then now we say if,
And now and then you can say like if your lights at row and call,
and yeah,
like if it's on, and if you what is divisible by 2, right?
yeah,
Or even, right? So you have to do mod 2 equals 0, right?
yeah. So yeah, then we want to say it's divisible by 2. So then we say that's equal to 0.
Yep.
Right there. So there we go. Yeah, light, row, and call. So that's saying if it's true, right? Or actually, no, you got to be careful, because if light is, oh no, actually, never mind.
No, that would work
Light
because it's
is
Boolean.
on.
It's a Boolean array.
Yeah,
So
the light is on, and then you can just be like return. Okay, we can be more strategic.
you could say return false.
You could say return false.
That's it.
Return. Yeah, you don't want to put a return statement right here because it'll end the code right there.
Yeah, then you do another if statement, right?
Or you'd be like else if.
Yeah, and
What is
then if not lights at row and column, and then and it's on, and it's what divisible by 3, so mod 3 equals 0, right?
Yeah, so if not, so like lights row
Yeah.
call represents what is it? It's on, right? So if it's not on, that means it's off, right? So not on is off. And then just say
No, and yeah.
and that's going to be right.
Mod 3.
Oh wait, no, I'm
No, it's mod 3. There you go. Yeah.
Then we return
True.
and then
I'd simply just return lights at row and column as your base.
Yep.
And I think, yeah. And the cool thing about it is this was relatively short. You got pretty code and you didn't have to think too much about it. So
yeah.
like one.
Only I think we could make this slightly better. We can be like, here's how I would make it better if I had time. Say like Boolean state equals lights row call. So then I would be
oh,
like,
that's genius. Yeah. You're
then what I
computing the
would
state
do
at each part, right?
I would be like, if this statement right here, because what is it? If the statement, okay, let me this statement, or this statement. So think about it. If the light is on, but then we want to return false, then we're opposing the state. So the state will be true, right? You'll be on right here, but we'll return the other state, which is false, if we have this divisible by 2. And vice versa. Let's say it was not on, right? If it off, right? If it was off, then we want to return its opposing state true if the number of lights in the column are divisible by 3. So what I'll do here, what happened? I'll say that
You can
state.
full screen your window.
Oh yeah,
You don't need to see the question. Yeah.
Yeah, state is equal to not state right there. So I'll just flip the state right there, and then yeah, I'll just. So for those specific instances, so let's say it is true, it is on, and it's divisible, the number on is divisible by 2, then we want to flip the state by saying it's false. And vice versa, we will be like, okay, if it's off and it's divisible by 3, then we want to flip the state and turn it on. So then you can just
You can just say
turn-
state. Yeah.
so that's, I guess, another way you can do this. But yeah, I mean, pretty code doesn't matter. The stuff that we had before would work, and yeah,
That would probably earn you more points. This is a risky line to play.
it is a really I wish
Because
they
say you got the first if statement wrong or the second if statement wrong, you'd still have one to fall back on. The fact that you put all of this into one if statement,
yeah, that's true.
and you got it wrong, then you have like try to maximize as many helper methods, as many things you can write without over indexing on it, so you can get the max amount of points if you lose points on something.
Yeah, I mean, what I would say is you could definitely go for this risk, but just write code that works. That's all. You're not going to be just write code that works. Just try to find the easy way. Try to make code that works. Of course, you want to be like quirky. The reason why I'm being quirky here is it gives you a good learning experience. It teaches you how to think, right? And I think that's super important. That helps you build your skills, just coding skills in general, right? But for the exam, if you're just thinking particularly about the exam, just write code that works. That's the simple solution that I could say right here. All right, so I think that is it for class information. Roll call. I think that's it for this for this question. Do you guys have any other questions that I could do, or do you guys have any other questions that you want to stick around for, or do you think it's a good time to end it here? Do you guys have anything? I'm up to you. It's up to you guys. I am going to take that as a no. All right, let's just, I think this is a good spot to wrap up. So if everyone in the chat can tell me one thing that you learned today, or one thing that you found useful. Actually, yeah, two things. One is like, tell me what you learned and what you found useful. And another thing is feedback. Give me one of each. And then you can just send them directly to me. And then once you do that, you're free to go. It's because I have two more sessions left to go. I have one for the calc and then one for
Was that today or the calculus is tomorrow, right? Yeah.
Calc is tomorrow and then physics is the day after.
Come to the cal. Oh yeah, the refresher. Yeah.
Morgan's and math at random syntax.
On
Okay.
the Morgan's law, I'm happy that it kind of helps you.
Yeah, I need feedback because I know this one like a lot longer than expected. So I'll try to keep it short. I'll try to come up with a better plan for calc. Is there any other?
Chendur has something called feedback inhibition. Sorry, that was an AP bio joke.
But any other feedback? I think I'll just end the meeting right here. Actually, not end the meeting. I'll stop the recording.
Yeah, recording. Yeah.
I should have stopped that, but all right.
You have like one